All right, hello and welcome. And today we are going to attempt something interesting. So I'll be installing the infrastructure for the OPS Bridge suite in AWS, and I'll be trying to use the minimalistic setups. The more minimalistic it is, the more I think that I win. So I logged in here with my credentials to AWS console. As you see, there are lots of machines terminating here for a good reason. And immediately we'll be starting with creating the machine. So let's pick a service name. I'll be student 83. Student 83, init machine. And this is the machine that we'll be using to run our stuff on it, at least the initial scripts, right? So we'll go with the instance types very small. I'll be using the access keys that I created earlier, and the VPC, of course. The VPC would be something else. What did I do with network settings? There we go. So, of course, it's going to be OPSB enablement. Is it enablement or just OPSB enablement? Let me see. Yeah, enablement VPC. Did I choose the right? Let's see if I can do enablement. No, it's just an OPSB enablement. All right. So I'll be using this VPC, public subnet, and I'll be choosing a pre-existing security group. Why? Because I'm running it so tight that basically only allowed IPs, like my own IP of my own router at home, can actually access anything that I create here, and everything else is internal. Why? Because, well, you want to be as safe as possible. All right, and then I'll be launching this instance. That is going to be pretty fast. So now, once I created this student, let's see, student 83. What did I do? I mistyped student. So we'll go with student 83. Where did my instance go? Oh, come on. What did I do? Did I do something wrong? Did I do something wrong? Hopefully, I meant init host. Admin, student. What did I do? What did I do? Oh, student 83. Okay, student 83. I thought that I did that. Maybe I was too fast. All right, now just copy the public IP, and I'll go ahead and create a student. Let's see, student 83 server. Now, as you see, I connect directly without modifying any settings, and there is another video for how to, in general terms, how to configure remote ng to work with private keys. So for me, it's all the same, but you will need to do some setup over there. Okay, and here we start running our trusty commands over here. So I'll be just copy pasting them. They are pretty generic. Everything is based on standard documentation. Although Although some of this documentation is going to be relying on older versions, but everything is work in progress. That's how we roll, and everything that updates pretty fast. So this is me installing and configuring the Python and a repository AWS CLI, basically adding a Perl release to the Linux, some basic stuff. You create a VM out of an empty template. You do need to put some more repositories in it. And specifically what we are looking for is the Terraform and AWS CLI to make everything work together. And there we go. This is our, I believe, Docker. Yeah, we installed Docker pretty fast. Now let's do the Terraform bit. And like always, install some utils, you add the repository, and then you install Terraform. There we go. Okay, so Yao install Terraform. Now I'll be downloading some of prerequisite packages. This is just for convenience. Everything is from Marketplace or from regular downloads. And specifically, this is Vertica, this is the OMT or previously known ITOM platform or previously known CDF. We have the latest chart for Ops Bridge itself. And the cloud deployment toolkit. The toolkit is the one that has all of the templates for Terraform, and it's available on Marketplace. So I just put all of those files in a convenient place, and now I just need to unzip all of them. Yep. Going there it goes. So there were a bunch of zip files, and now I unzip them all. Let's see that I have everything that I need. OpsBridge chart, OMT, cloud, yes. Okay, now here we start with a very specific. So the cloud toolkit, it's the one that I put here, and we'll be going there pretty soon. Okay, from this point, this is like real knowledge. Before that, that was like prerequisites. Download the file, deploy the file, go for it, and that's about it. But now we're going with the specifics. So the way the cloud toolkit works, we'll go to the cloud toolkit. No, we wouldn't go. Basically, some of those files that I have over here needs to be put in a specific folder because the templates would be expecting the files that it's going to use in a specific folder, right? So for me, in this specific case, the files would be copied into the underlying cloud folder over here. So just copying those 3 files, and then I'll show you where they are. Okay, so I'll go to the cloud folder. This is the cloud toolkit extract, and it has ITOM software. So if I'll list ITOM software over here, as you see, we have the Pulsar, we have which comes from the extracted OpsBridge switch chart. We have the OMT installation or the CDF with the ITOM platform. Let's call it OMT from now on. So just the zip file and the Vertica RPM file. This is all that it needs. So now we will go to the AWS folder, and here we'll go to the Terraform ITOM. Okay, so the models is basically a bunch of templates or already setups, let's put it this way. And ITOM SA, this is where you actually modify some of the files that you will need later. But first, let's configure AWS. I'll stop my recording for a second. And the reason was it actually asked me secure information, which was just showing on the screen. And I didn't want to share it, although I will destroy everything because I do for every run. But still, you never know, you need to be very careful. So that's one thing. Now we need to set some specific ECR related. Is it ECR? Yeah, it's ECR related variables. Basically, it will connect to the account, and then it will interact with ECR and do everything that it needs, but based on the previous AWS configure settings, right? So now let's do a little bit of deployment. We have this template .tfwars, and here all the magic happens. So I'll be setting the prefix, which is not mandatory, but still I would be setting it to student 83, and that would be like a domain prefix. And also I'll set ownership because I want to be able to track everything that I have in the configuration in AWS console. Right? So imagine yourself, I'm going to teach a class of like 30 students per week, 3 weeks. I need to be able to know who has what and where it belongs. And here, the allowed cloud client CIDRs, this is where I define what can actually go into my setup over here. Right? And I need to put here 2 things. The Terraform, the cloud toolkit, or which has the Terraform, will create a cluster which allows only its own components to talk to each other. It's encapsulated. So the only place where it asks, can actually something external go to one of the places would be the Bastion node. And we need to set up the 2 places. One would be in my own computer because I want to access from a browser the OpsBridge suite itself. And another one would be the init server that we created right now. This is the server that runs those scripts, so it needs to be able to access. So here is the only place where we put them, and as you see, I am going to be using only 2 IP addresses for the whole thing, right? So we put CIDR, it means that we need to put /32, and this is in JSON format, so I need to put it like this. And what is my IP? Very useful Google search. It will give my current IP, which is it's based on ADSL, so it changes from now on. And so it's very annoying because practically every day I need to go to AWS console and modify my own IP in the security groups. But that's what you get for AWS, for ADSL. Okay, now the nodes here are too large, I don't like such large nodes because, well, I'm a POC guy, and POCs are very minimalistic, and that's exactly what I like. So I'm going to replace them with T3 instances, but not just T3 instances. Oh no, I'm going to use the AMD processor instances because they cost like 2 cents less. Yeah, and it's going to be only 3 nodes. The Postgres is, it's okay. This is not big, not small. As you see, all of the passwords are default because we don't care. Everything is encapsulated. And then, this is the MC, which we don't care. Now, this is very expensive for Vertica. I'm going to use very minimalistic Vertica as well. So basically, it's going to be C5 to X large. If you'll go and look for those settings, what they mean, you'll see that, first of all, they are accepted in the Vertica realms, let's put it this way. And another thing is that it's pretty large, but pretty cheap compared to the alternative. The previous machine that you saw, it was like 128 gigs of RAM, unlimited, like huge amounts of CPUs, and 3 of them, right? So, no, we don't like that. And that's all the settings that I'm going to change. Everything else is going to be on default. Of course, if you do a production environment, you need to change. If you're doing a POC environment, no real need to change that because, well, again, it's all pretty secure. It's all encapsulated. There's no external access. It's on a VPC level, on a firewall level, on an account level, you name it, it's there. Okay, and the last thing would be actually changing the domain to an external one. Why? Because first of all, I have this domain and OPSB enablement.com. Okay, and that's the only setting that we're going to change in the variables itself. So I own this domain, and also I want to connect it to external domain. So the way routing works in web servers is, when you click a link or do whatever, there is like a substitute for the prefix or for the domain name itself, right? So even if you create access from outside, you need to make sure that internally the application knows what would be the general URL, the FQDN that's going to be used in every single API call and everything. And it's specifically for routing. It doesn't matter. That's for another video. But definitely, you want to control this, and you don't want to keep the defaults, because with defaults you would have to create some internal weird domains, or you would have to create internal jump machines inside the private VPC that the Terraform script is going to create. Right. So the environment that is going to be created, it's communicating with itself, right? From outside, you can access it only from 2 locations. One of them would be your machine or the init host. But from outside, what we mean is the Bastion node. It's the node where you run some more scripts, basically. It's useless in terms of going to the product itself. To go to the product itself, you would have to create another machine inside this private VPC, and only then you will be able to see some UI if you use the defaults. We don't want that. I don't want that, because that's just too much work. And frankly, paying for more machines, I don't like it. My account is very limited in budget. Okay, so now what we're going to do, we're going to actually execute the install steps. Yes, that is right. So there is SSH agent. Now we'll init the Terraform. There it goes. It tries to figure out everything that it has. There's like internal structure. Right? It's not like in the general. Okay, and then we're going to be planning the Terraform. Basically, that's like a small sanity check, but very small. It doesn't go to all places. It goes over the files, over the internal structure, and maybe some of the stuff that it sees right here. Okay, and that's about it. And it means that when you apply it, it doesn't necessarily mean that the plan was giving you correct details. Okay, but at least if the plan has errors, it will save you time. If it doesn't have, of course, we'll find out. So now we are applying. It's a Terraform apply. Apply means that go and actually perform all of the stuff that was in all of the templates, right? We modified some of the settings, but there's like a template for every single security group, port, internal module, the machines that it creates, the RDS, the EC2, the EKS. 1 second, we need to answer yes for the deployment. The whole clustering, storage, Route 53, all of it, right? All of those settings exist in the templates, but we just changed some small inputs that actually control the size of the environment and the general appearance, like how it looks like, what the domains are. And that's about it. And now it will actually go and create a bunch of stuff. And it takes like 15 to 20 minutes because it spins up a lot of machines. It creates all of those and it's not in parallel, right? You cannot really create a VPC group and what them called interfaces or not gateways or anything if the VPC group is not created yet, right? It's sequential. You cannot assign EC2 instances to this VPC group if you didn't create the VPC group, right? So same goes for clusters. So it's very sequential. It's linear. It's not too much parallel, which is completely fine. So we will let it run and we'll be coming back here in a couple of seconds. By the way, what's important is when Terraform fails, it actually knows what it did before. So you can go into AWS console and fix whatever you want, and then run the command again, and it will just continue to the same place where it was. And it's also very convenient for destroying your work if you change your mind and you would like to try from scratch. Then you just run Terraform destroy and it just reads everything that it created before and deletes everything that it created. So you don't need to go to like 50 pages in AWS and delete everything manually. You can just do it from one single place. And now it creates the EKS cluster, and this one takes a little bit of time. So let's skip that part. Okay, and this means that all of it is done. So what do you see here is some interesting things, right? So first of all, well, it gives you some output where your database server name is and everything, but also it creates a lot of private files for accessing everything else. When you'll go to the console, you'll see that basically it created several servers. This one is actually a vertical server. It has a weird name. There is the Bastion, there is the controller something, vertical controller server, vertical management server, and 3 workers that are unnamed, but gladly we have tags, I think. This is how it finds them. Yeah. So based on tags, when you search for your stuff, it's actually there. But it goes much, much, much beyond that, right? So let's look at load balancer. I think it did not create one yet, okay? But when you go to RDS and you refresh the page, you see, well, there it is, student 83. When you go to Route 53 to hosted zones, there it is. It's a new zone that it created. You can even look inside and find that there is a Bastion A pointer to the Bastion node itself, which is fantastic. When you will go to VPC, come on, go VPC, there's going to be a whole VPC cluster just for this record, right? So let's select one of them from the drop-down list so it would filter everything. And that's going to be student 83 VPC. There we go. Okay, and we can see the subnets. There is all of those subnets for student 83. You see, it filters out everything. So subnets for workers and for Vertica and for databases and just for other stuff. And there is a routing tables for per environment, basically. There are internet gateways, and there's also a bunch of security groups. Oh, come on, where groups, network ACLs. I think there was access to security groups somewhere here. Usually I don't go from here, I go from EC2. And yeah, lots of security groups, each with its own rules that allow other security groups to get in, or internal communication. You see, there's not many entries, but the point is that when we go to Bastion, the inbound rules include only those two IPs that we input into the allowed CIDRs in the script, right? If we will check other inbound rules, we'll see that it's all internal. So basically, we have access only to the Bastion and nothing else. Okay, whatever we want to go, it's not going to be going there. So that is it. I mean, we can go to EKS and see our cluster somewhere here. Come on. Okay, there it is. Yeah, so we have the cluster created, and we can go on the inside and look at it and everything else, but that's not the point. The point is that this is how you create the internal infrastructure. And from this point on, it's a next chapter, which is how to deploy OMT or CDF or ITOM platform, right? So far, it was the infrastructure. As you see, it created all of the nodes into the network, all of the utilities, security groups, everything that you need, except for deploying the actual things that that come from the OPSB suite or from ITOM itself, which is going to be the next step. So I'll see you in the next one.